elasticity of demand measures how responsive the quantity demanded or your sales are going to be to a change in the price of the product. So like a rubber band, if you pull on the rubber band a certain price cut, for example, if it's an elastic rubber band, it's going to result in a big change in your sales. So elastic demand means that you pull on the rubber band with a certain force, and if demand is elastic or sensitive to price, there's going to be a big change in sales. An inelastic rubber band, you pull on it with the same force, and the rubber band doesn't move much. So the quantity demanded, or your sales, are not going to change very much if demand is inelastic or not very elastic. In this slide, we're looking at how responsive the quantity demanded for ambulance rides, how responsive it is to a change in price. So if we started out initially with a price of $100, we would be selling 10 million rides. If the price increases to $210 a ride, a significant increase in the price of ambulance service, what's going to happen to the quantity demanded? In this graph, it decreases, but it only decreases from 10 to 9.9. So here you have a relatively large price change and a relatively small change in the quantity demanded. So here you would argue that demand is not very elastic or inelastic. It's like the rubber band. You make it, you pull on it a lot, and it only stretches a little bit. So this is an example of a service that would not be very responsive to price changes. In this slide, we start with a demand curve. And here, if you increase the price from $40 to $50, the sales drop from 80 to 75 along this demand curve. I'll call it D1. Okay, now we introduce another demand curve that goes through the same initial price point, but now when we increase the price from $40 to $50 for this product, we'll call this one D2, you can see that it results in a big decrease in sales from 80 all the way back to 20. So in this case, the demand for product 1 is inelastic, not very price sensitive, but the demand for product 2 is elastic, meaning that it's price sensitive. The same increase in price resulted in a much bigger drop in sales. Elasticity is not the same as the slope of the demand curve, but as in the previous slide, if you have two demand curves that intersect at the same price point, the flatter curve, or the one with the lower slope coefficient in magnitude, is going to be more elastic. And we'll discuss this further. Specifically, the price elasticity of demand is defined by the percentage change in the quantity demanded divided by the percentage change in price. So in this example, if we have a product like oil, and if the price of oil increases by 10%, here we have a 10% increase in the price of oil. What happens? The sales of oil in this example fall by 5%. So according to our definition, the price elasticity of demand is equal to the percentage change in the quantity demanded divided by the percentage change in price. So we do the calculation, we come up with a price elasticity that's equal to minus 0.5. And so what that means is if you increase price by 1%, sales would fall by 0.5%. And this is just applying our price elasticity formula. And when we do this, we can actually, once we know our price elasticity, it's basically if you know what the change in price is, and you knew the price elasticity was minus 0.5, you could calculate how a change in price is going to affect the quantity demanded. So just by using arithmetic, if you know two of these three values, you can calculate the third one. In this example, we knew the price and the change in quantity, and we calculated the price elasticity. We could also, if we knew the price change and the price elasticity, we could calculate what that meant in terms of sales. And because if we have a downward sloping demand curve, we know that there's an inverse relationship between price and the quantity demanded. So when we see price elasticities listed in table, drop the minus sign and always assume that the sign is negative for a price elasticity. When we do an actual calculation, given 2 points on our demand curve, when we calculate a percentage change, it depends on what starting point you're using. And typically what economists do is calculate price elasticities at the midpoint or the average price in the average quantity. And we'll see that in the subsequent slide, how we calculate price elasticities using this midpoint. So when we calculate the percentage change, here it could be the percentage change in price. What we're doing is we're taking the actual change in price, and the base that we're using to calculate the percentage change is our average price. And then to put it in percentage terms, we multiply by 100%. Price elasticity calculation, we'll see how that midpoint method works. Okay, here we're saying that the price of the product is initially $10. And when the price is $10, the quantity demanded is 100 units. Then the price increases from $10 to $20, and the quantity demanded decreases to 90. So now if we calculate the percentage change in quantity demanded, we have the new quantity demanded minus the original quantity demanded. So the actual change is the quantity decreased by 10 units. Then we're going to use the average quantity when we calculate our percentage change. So the average is just 100 plus 90 divided by 2, or 95. So when we calculate the percentage change in quantity using the midpoint method, we're going to get minus 10 divided by 95, and that's going to be equal to a minus 10.5% change in quantity. Okay, then to calculate the percentage change in price, we take the new price, which is 20, minus the original price, which is 10. So the price went up by $10, and we're using the average price as the base. So if we take 10 plus 20 divided by 2, we get an average price that's equal to 15. So when we're calculating the percentage change in price using this midpoint method, it's 10 divided by 15 times 100%. So that would be a 66.6% increase in price. So now we plug this into our price elasticity of demand formula. You get a 66.6% increase in price, the percentage change in price. And in the numerator, we get the percentage change in quantity demanded, which is a minus 10% decrease in the quantity demanded. So if we calculate the price elasticity of demand, it's 10.5 divided by 66.5, which is equal to minus 0.15, which is inelastic, because we have a relatively big increase in price in percentage terms and a relatively small drop in sales in percentage terms. So we wind up with a price elasticity of demand that is relatively low. And again, we say typically you'll disregard the sign because you know that the sign is always going to be negative. Economic studies, they typically collect historical data and use regression analysis to estimate price elasticities of demand for various types of commodities. And by definition if the magnitude of the price elasticity of demand, in other words, the magnitude meaning if we take the absolute value of it, look at the magnitude, if it's less than 1, if it's a fraction, we say demand is inelastic. So here for gasoline, in the short run, demand is highly inelastic. In the long run, the demand is still inelastic. 0.24 is less than 1, but it's not as inelastic as demand in the short run. Now we look at airline travel. For business purposes, the demand is inelastic. This 0.8 is less than 1. The demand for soda is inelastic. The demand for college tuition is inelastic. Elastic demand, it means that the magnitude of the price elasticity of demand, in other words, disregard the negative sign, is greater than 1, which means that this is greater than 1 if demand is elastic. So the demand for housing is elastic. The demand for out-of-state tuition is elastic. The demand for leisure airline travel is inelastic. And the demand for Pepsi and Coke, which is a specific brand of soda, is elastic. And so this gives you an idea of the wide range in elasticities across different products. And later on, we'll look at why certain types of goods and services, why demand is not very responsive to price, and for other things, demand can be highly price sensitive. Again, by definition, if the magnitude of the price elasticity is less than 1, demand is inelastic. If it's greater than 1, demand is elastic, and if it's equal to 1, we say it's unitary elastic. This slide shows a limiting case. Here it's showing that you can have an increase in price arbitrarily high, and the quantity demanded stays the same. So what it's saying is, if you calculate the price elasticity of demand, the percentage change in the quantity demanded is equal to 0, even if you have a big change in price. So this means that demand is perfectly inelastic, meaning that the price elasticity is equal to 0. Take price as high as you want, and there's not going to be any change in the quantity demanded. And it's like a hypothetical case. Think of it as as a drug like AZT that you need in order to sustain your life. If income wasn't a constraint and you could afford it and you needed it to live, it wouldn't. Here we have a situation with this demand curve that's horizontal. Here it means that if you change, you could view this as like a really, really flat demand curve. And here you could say, well, even a really small change in price, if we started with the price that was here, and we increase price a little bit from here to here, we get a big change in the quantity demanded. So you can see if this demand curve were really flat, that a small change in price would result in a big change in the quantity demanded. Well, here, a perfectly elastic demand curve that's horizontal, it means that like even a tiny incremental change in price results in an infinite amount of quantity demanded. So if you decrease the price a little bit, your sales would increase arbitrarily large. And this would be a situation if you're in a perfectly competitive market, and I'm producing corn, and you're another corn grower, and our corn is exactly the same. If the market price is $5 and I lower my price a little bit below that, everybody's going to buy the corn from me. If I increase my price above $5, everybody's going to buy the corn from you. So it's a hypothetical example, but it shows that in some markets you can have demand that's highly sensitive and highly elastic to price change. Unitary elastic just means if you increase the price by 20%, your sales are going to go down by 20%. So the impact in percentage terms on price is the same as the impact on sales. So if demand is inelastic and you increase price by 20%, your sales drop off by 20%. And later on, when we look at total revenues are price times quantity. So that if demand were unitary elastic, if you increase price, your sales revenues would stay the same. Now here, along our demand curve D2, we see that, well, if we increase price by 90 cents to $1.10, which is a 20% increase in price, if we use the midpoint method, it's going to result in a 10% drop in sales. So if we calculated our price elasticity of demand, now, what do we see here? We say basically, oh, okay, price goes up by 20%, sales fall by 10%, our price elasticity is equal to minus 0.5. And minus 0.5, if we take the magnitude of it, it's less than 1, so demand would be inelastic because it's equal to 0.5. Next example for product D3. Okay, for product D3, we start with an initial price of 90 cents, the initial price. Our sales are $1,200. We increase our price from 90 cents to $1.10. If we use the midpoint method, that's a 20% increase in price, but the resulting drop in sales is 40%. So what's the price elasticity of demand? It's the percentage change in sales, which is sales go down by 40% as a result of a 20% increase in price. So here our price elasticity is equal to -2. Or if we forget about the negative sign, its price elasticity is equal to 2. So here you can see demand is elastic, which means that it's a lot more price sensitive than the previous slide. And technically, in order to be elastic, it means that the percentage change in sales has to be greater than the percentage change in price. So what it means is what's in the numerator, the percentage change in sales, has to be bigger in magnitude than the percentage change in price. So when demand is elastic, you're always changing sales by a bigger percentage than the price change. And now we look at total revenue, it's the price that you charge times the quantity demanded, or the amount that you sell. So total revenue is always price times quantity. So if you looked at total revenue, it's the price, 90 cents, times the quantity, 1,100. So total revenue would be 900. In this example, we start off with price times quantity. And then now we increase the price from 90 cents to 110. It decreases the quantity. So we'll see, well, what happens to total revenue in this case? And you can see, well, this is revenue that you gained because the price was higher. Revenue that you lost because at the higher price you didn't sell as much. So this is basically revenue that you lost based on the decrease in sales, and this is revenue that you gained based on the increase in price. So now what happens to total revenue? Well, if the revenue that you gained, if the percentage change in price is greater than the percentage change in sales, your revenues are going to go up. But if the percentage change in sales is greater than the percentage change in price, your revenues are going to go down. So we'll see what that means. And what it means is that, well, okay, when demand is inelastic, it means that the percentage change in price is going to be greater than the percentage change in sales. So what does that mean? It means if you increase price, the price is going to go up more in percentage terms than your sales do. And what's going to happen to total revenue then? You know, total revenue is equal to price times the quantity demanded. And if you increase price by, say, 10%, and demand is inelastic, let's just say your sales fall, but they only fall by 5%, what's going to happen? Well, basically the price goes up by 10%, your sales fall by 5%, your total revenues are going to go up. It's not going to be completely additive, but roughly, approximately, your revenues would go up by approximately 5%. And that's what we're seeing here. So when demand is inelastic and you increase price, it's going to result in an increase in total revenue. And that's why when you have public transportation, like Southeastern Pennsylvania Transit Authority, SEPTA, subway fares or bus fares, when they try to increase revenues for those public transportation, in order to increase revenues, they impose price increases, because the demand for public transportation is relatively inelastic, and when you increase price, the percentage change in price is more than the drop off in sales, so that your revenues go up. So what if the demand for your good or service is elastic, like the demand for leisure airline travel? The price elasticity of demand was 1.5. So if we increase price by 10%, what's going to happen to our sales? Our sales are going to drop by 1.5 times 10. Calculate X here. It's equal to 15%. So what happens to total revenue? Total revenue is price times your quantity demanded. And if you increase price by 10% and your sales fall off by 15%, guess what? Your total revenues are going to go down by approximately 5%. So here, if demand is elastic and you increase price, it's going to result in a drop in total revenue. So what airlines do, especially in the the shoulder seasons, the off-peak seasons, like if you're flying from New York to Geneva, Switzerland, anytime in the winter or early spring, it's the demand for airline travel is relatively low, and what the airlines do is they drop fares in order to increase their revenues. So what happens here, if you drop fares by 10%, the quantity demanded is going to go up by 15%, and your total revenue actually increases because the price effect, the percentage change in price, is less than the percentage change in sales. So when you lower price by 10%, your sales go up by 15%, your revenues increase. So if demand is elastic and you want to increase revenues, you've got to lower fares, the way that airlines do in the off-peak seasons. If demand is unitary elastic or close to 1, if you increase price by 10%, your sales are going to fall off by roughly 10%. So changes in price don't have any effect on total revenue when demand is price elasticity is equal to 1. An interesting property of linear demand curves, meaning straight line demand curves, is that the price elasticity of demand changes if you calculate it at different points on the demand curve. And so what we've shown here is that when prices are relatively high, demand is elastic. And we can see that lowering price has actually increased total revenue when we lowered price from $10 to somewhere in the vicinity of $6. So over this range of prices, from roughly 10 to 6, demand were elastic. So when we lowered price, we actually increased our revenues. But as we moved down the demand curve, we see at prices roughly below $5, the demand is inelastic. So when we continue to when we set a price of $5, our revenues are maximized. Then when we lower prices from $5 to 4 to 3 to 2 to 1, demand is inelastic over this range of prices, and lowering prices below $5 actually decrease their total revenue. And that's because along a linear demand curve, the price elasticity of demand changes depending on what price and quantity you're calculating that elasticity at. So it's interesting to look at a linear demand curve and realize that at low prices, demand is inelastic. At higher prices, demand is elastic. Here, if you're operating an apparel store and you're interested in maximizing your revenues and you increase price by 25%, what does that imply about the price elasticity of demand? Well, if you increase price by 25% and you're trying to maximize your sales revenues, then it makes sense if the demand for your product is inelastic, because if you raise price by 25%, your sales fall off by less than 25%, and your revenues go up. So here, a price increase, if you're concerned about in total revenue and profits in this case, if demand is inelastic, that makes sense. What determines the price elasticity of demand for a good or service? One factor is the availability of close substitutes. If you're producing a product and increase the price and your consumers have the ability to switch over to other products that have similar product characteristics, the demand for your product is likely to be more elastic. If there aren't any close substitutes for your product, demand is going to likely be less elastic or more inelastic. The demand for a product tends to be more inelastic if you're dealing with a necessity. Here you have different food staple groups like eggs or the food that you typically buy are more of a necessity, or gasoline. And that's why when there's a change in the price of a necessity, sales don't drop off as much as if it were a luxury product, like vacation travel, for example. A luxury good, demand tends to be more elastic or more price sensitive. If you're dealing with a product that only takes up a small percentage of your budget or your income, it tends to be less price sensitive. So when they estimate the demand, price elasticity of demand for matches or for salt or for other types of low cost ingredients, demand tends to be more inelastic because it's just such a small percentage of your income. If the price of salt or matches doubles, you're not going to be very likely to cut back on quantity because it's just has such a small effect. But things that take up a larger chunk of your income demand tends to be more elastic or more price sensitive. The length of time that you have to adjust to a price change is really important. And typically when consumers have a longer period of time to adjust, they're able to, in response to a price increase, they're able to cut back more. So gasoline is an example where the price elasticity of demand in the short run is extremely low. When we looked at the chart, it was extremely low. So what that means is, you need a certain amount of gasoline to get to school or to get to work and do other things. In the short run, you might be able to cut back on some discretionary trips to the mall, but you're not going to be able to cut back in a big way in the very short run. If you have a longer period of time to adjust, you can find someone perhaps to carpool with. You can buy a more fuel-efficient car. You can move to a location where your commute isn't as long. But those are adjustments that you can make over a longer period of time. So typically, the long-run price elasticities of demand, when consumers have a longer period of time to adjust to the price increase, they're going to be able to cut back their consumption of gasoline a lot more in the long run than they can in the short run. Now, if we look at demand relationships more generally, we could say, well, okay, the quantity demanded for any particular product based on economic theory is going to depend on the price of the product itself. I'll just call it, the price of the product itself, and it's going to depend on the price of any substitute good that might be available, or the price of any complement good that might be available, or consumers' income, and other factors as well. But based on economic theory, these are typically the factors that affect the demand for most products. So if we're estimating the demand for new automobile sales, domestic automobiles, it would depend on the price of domestic automobiles, the price of substitute goods like imported automobiles, the price of complement goods, which are things that are consumed with automobiles, which could be something like the price of gasoline, or it could be the price of financing your new automobile, and also income typically is a demand shifter. So when we look at these factors, the demand curve shows the relationship between price and the quantity demanded, assuming these other factors are held constant. And what we did with price elasticity of demand sometimes it's called ohm price elasticity of demand. It looked at how sensitive sales were, quantity demanded, given a change in the price of the product itself. But we can measure how responsive sales are to a change in the price of a substitute good, or the price of a complement good, or a change in income. And we do it the same way. It's the percentage change in sales given the percentage change in the price that we're talking about. So when we talk about cross-price elasticities, we're looking at changes in the price of either substitute or complement goods. When we look at income elasticities, we're looking at the percentage change in income. But either way, we're looking at how responsive sales are to those changes. So our cross-price elasticity, yes, sometimes it's called, cross-price elasticity of demand. It's the percentage change in the quantity of the good that we're looking at. Here, good A, given a change in the price of some other product, which we're calling good B, which could either be a substitute or a complement. But by definition, the cross-price elasticity is the percentage change in the price of the sales that you're analyzing, given a change in the price of some related good. If you have two goods that are substitutes, the cross-price elasticity is going to be positive, because here you have two different types of cookies. Well, let's say you're analyzing the demand for this type of cookie, and if you change the price of this cookie, well, if you increase the price of this cookie, if you increase the price of this cookie, how is it going to affect the sales, the quantity demanded for this cookie? I'll call this cookie 1 and this cookie 2. So if you increase the price of cookie 2, what's going to happen to the demand for cookie 1? Well, presumably they're substitutes because they have similar product characteristics, and if the price of this one goes up a lot, the demand for this one is probably going to go up. And by definition, if they're substitutes, if you increase the price of the one, the demand for the other goes up. And that's why the cross-price elasticity has to be positive. So if the percentage change in the sales of cookie A divided by the percentage change in the price of cookie 2 is going to be your cross-price elasticity. And if they both move in the same direction, they have to be substitutes. And here the cross-price elasticity for complements. The textbook case of two complements would be if you're estimating the demand for cookies or Oreos, and some people like to consume milk or coffee with their cookies. So here, if you estimate the cross-price elasticity, you're estimating the demand for Oreo cookies. What happens if there's a change in the price of milk, or if you're at the Swigert kiosk and you're estimating the demand for those big chocolate chip cookies, and you get there and they say, well, actually the price of a coffee, we're giving it away now. The price of coffee goes from $1.50 to $0. How is that going to affect the demand for those big chocolate chip cookies? Well, if they're complements, you decrease the price of the complement good, the coffee or the milk, it's going to increase the demand for cookies. So you're decreasing the price of the one, it increases the demand for the other. So the sign of the cross-price elasticity has to be negative. Here we can do a cross-price elasticity of demand. Cross-price elasticity of demand calculation. We're looking at here we're saying that this is the percentage change in the quantity demanded for good A divided by the percentage change in the price of good B. So here's good A and here's good B. And you're estimating the demand for good A. So here you say, wow, the demand for good A decreases by 6%. At the same time that the price of good B increases by 4%. So what does this equal? It's equal to minus 1.5. So you increase the price of the one, and it decreases the demand for the other. Now, our A and B substitutes or complements. Well, we know that if the sign is negative, you have a complement. And in this case, you're increasing the price of good B, it decreases the demand for good A. So we know these are complements. So if you increase the price of coffee at the kiosk, it's going to decrease the demand for those big chocolate chip cookies if they're complements. Income elasticity demand looks at the percentage change in the quantity demand for some product divided by the percentage change in income. So it's looking at how responsive sales are to a change in income. And there's two types of goods. Normal goods are ones where if you increase income, you're going to buy more of their product. And most goods and services are normal goods. Basically, if your income goes up, you're going to likely, you're going to eat away from home more often. You're going to be more likely to buy a new car. You're going to be more likely to buy more clothing and so on. So most goods typically will be normal goods, where if your income increases, you will buy more of most things. But there are some things that would be inferior goods, meaning if your income goes up, you might actually buy less of that good. It could be used clothing, could be an inferior good for some people, or inferior cuts of meat like a hamburger or hamburger helper, or other types of things. When your income goes up, you may actually decide rather than buy used clothing, you're going to go out and buy new clothes, for example. Or instead of getting a used car, you might get a new car. So for a normal good, you increase income, sales go up. So the sign of that income elasticity is going to be positive. Inferior goods, income goes up, sales go down. You demand quantity demand that goes down. So the sign of an inferior good is the income elasticity is going to be negative. Here they point out if you have a normal good, it can be referred to as income elastic. It's more common to refer to this as a cyclical normal good. And that means one that if you increase income by, say, 10%, that sales are going to increase by more than 10%. So it's a good that's highly correlated to changes in income. And that typically would be things like consumer durable goods, like automobile demand, for example, or appliance demand, as those tend to be highly correlated to income changes. So if the economy is doing well and incomes are increasing, there generally is a big increase in the demand for automobiles and other things that would be considered cyclically normal goods. On the other hand, if you expect the economy to be entering into a recession, you'd expect with incomes going down, you'd expect the sales for new cars, home furnishings, appliances that are cyclically normal, you'd expect the sales to take a very big hit. So if income went down by 10%, sales for those products are going to go down by more than 10%. So if you're an investor expecting an economic slowdown or a recession, what you want to do is get out of the stocks for companies where demand is cyclically normal. But when the economy starts to pick up and do well, and incomes are expanding, those are the industries that are going to do the best. Consumer staple goods, on the other hand, do not respond much to changes in income. So Wow, here they're analyzing one of my favorites, ramen noodles. Here for Tanya, when her income is 40,000, she consumes 10 boxes of ramen noodles. But when her income drops to 30,000, she consumes 40 boxes of noodles. So you can see when her income goes down, her consumption goes up. So that means it has to have a negative sign, which means that for Tanya, this is going to be an inferior good. Okay, so now if we calculate the income elasticity, basically the income elasticity of demand, it's the percentage change in sales of ramen noodles that result from a percentage change in income. So here, what's our percentage change in income? Our income goes down by 10,000. The actual change, it decreases by 10,000. If we use the average income as the base, it would be the average income is 35,000. 40 plus 30 divided by 2. So in percentage terms, this is going to be a 28.6% decrease in income. So our income decreases by 28.6%. What happens to our sales? Our sales increase. It increases by 30 boxes. The base we're using with the midpoint method is the average base. So 40 plus 10 is 50 divided by 2 is 25. So if we take 30 divided by 25, that gives us 120% increase in our quantity demanded when our income fell by 28.6%. So if we do the math, that income elasticity has a negative sign, an inverse relationship, and the magnitude of it is going to be minus 4.2. And so what does that mean? It means it's an inferior good, and it's highly cyclical, because the magnitude of this is greater than 1. So here we have something that's an inferior good that's highly cyclical. And even though this represents Tanya's preferences, I would have to tell you, if my income decreased, I probably would consume about the same number of boxes of ramen noodles that I do now. And if my income increased, I probably would consume about the same number. So for me, my demand is probably not going to be very income sensitive. But in this case, we have an inferior good that's highly income sensitive for Tanya. Okay, we can also assess how responsive the quantity supply it is to a price change. So in other words, when you increase the price of the product, typically sellers are willing to sell more, but how much more? Okay, the price elasticity of supply is the percentage change in the quantity supplied given a percentage change in price. So this is analogous to the way we calculated our own price elasticity of demand, except we're calculating it now along the supply. And our limiting cases, what's the price elasticity of supply here? Here we can change price arbitrarily high, and it actually has absolutely no effect on the quantity supply. So that means that the price elasticity of supply is equal to 0. If we have a supply curve that's horizontal, here you're saying a very small infinitesimal change in price is going to result in a huge change in the quantity supply. So this is known as perfectly elastic supply. And if we calculated it, it actually approaches infinity. So you can actually have an arbitrarily small price increase that results in arbitrarily large increase in the quantity supplied. And here's our supply curve. And here we're saying, well, okay, we're increasing the price from $40 to $50. The quantity supply goes from 80 to 85. And here we're saying it's a relatively large increase in price and a relatively small increase in quantity in percentage terms. So that would be, supply would be relatively inelastic. Okay, we compare this to our second demand curve for a different product. And here we say, well, we've got the same price increase from $40 to $50. But what happens to the quantity supplied? It goes from 80 to 170. So here you can see the percentage change in price was the same, but the percentage change in the quantity supplied is much greater. So again, if we have two supply curves that intersect at this point, we can say that the flatter curve, along the flatter curve, supply is more elastic, and the steeper curve, supply is less elastic or more inelastic. And the same thing, elastic supply means a relatively small change in price increases the quantity supplied a lot. Inelastic, the same change in price only increases the quantity supply a little bit. And what makes the supply of a good or service relatively elastic? Well, if you're looking at a situation where if the price of the product increases, how easy is it to expand production of that product? And if there are a lot of inputs available, it may be relatively easy to expand production. But if some of the crucial inputs are limited, it might be difficult to expand production. If you look at mid-continent oil production, let's say, from these shale deposits, when the price of oil gets somewhere between $60 to $70 a barrel, a lot of these geological formations become very profitable. And at that price point, if the price goes above, let's say, $70 a barrel, it provides an incentive for domestic producers to put in more oil wells because they know at those prices they're going to be profitable. So the supply of domestically produced oil is highly elastic at those price points where oil production is really profitable. There's enough available inputs to do that, and it just takes time to put in the well, and the elasticity of supply is very elastic once you reach those profitable price points. On the other hand, if you look at the supply of rental apartments in Manhattan or San Francisco, even if you have a significant increase in rental prices, there just isn't available land that's easy to develop into new rental units. So the availability of land is extremely limited, which means that the price elasticity of supply for rental units in metropolitan areas is going to be highly inelastic. And when you're looking at price controls for rental apartments, it's like, hey, even if the rental price goes up, guess what? The market isn't going to be able to produce very many more rental units. And that would affect your public policy decision, probably. Another factor is time. In the long run, when the price of a product goes up, in the long run, you can put more production capacity into place, and you have more of a time to respond to that price increase. So same thing. Short-run price elasticity of supply tend to be lower or more inelastic than long-run elasticities. Here, if we look at these supply curves, along which supply curve is the elasticity of supply going to be more elastic. And assuming S4 is a perfectly horizontal supply curve, we know that the price elasticity of supply is perfectly elastic, or equal to infinity. The next most elastic curve is S3. And you can see if you increase the price, the quantity supplied, along S4 is going to be approach infinity. Along S3, if you increase the price to P0, the quantity supplied is going to increase to, I'll call this Q3 for good 3. For good 2, the quantity supplied would increase when you increase price, but it only increases to Q2. And along S1 supply curve, you increase the price from the initial price to the new price, and the quantity supplied increases, but it only increases a little bit to Q1. So you can see that the flatter the supply curve, the more elastic supply is going to be, which means if the price of the good goes up, the supply response is going to be much greater for good S4 than it is for good S1. This is the rental apartment in San Francisco. This is the domestic oil production once you've reached a profitable price point of somewhere in the vicinity of $70 a barrel. Okay, if there's an increase in the price of housing in Manhattan, is the quantity supply going to be higher or lower than the same percentage price increase in Des Moines? Well, graph both. Well, the supply curve is going to be more elastic in Des Moines market than it is going to be in the Manhattan market. So you could flip to the previous graph and show that if you have an increase in the price of housing in Manhattan, it's going to result in only a small increase in the quantity supply. But in Des Moines, the supply response would be much greater.